dipole moment, and I will teach you my personal trick through which you can find dipole moment of any molecule in less than 10 seconds. Firstly, let me teach you that what is dipole moment. Well, it measures the net polarity of any molecule. Note it down that dipole moment is denoted by Greek letter mu. Its formula is mu is equal to Q into D, where Q is the charge on an atom and D is the distance between atoms. Also remember that dipole moment is a vector quantity. Its direction is always from positive charge to negative charge. Or we can say that its direction is from less electronegative atom towards more electronegative atom. Secondly, you should learn about polar molecules and non-polar molecules. For example, consider hydrogen fluoride molecule. We know that fluorine is more electronegative, so it will attract the shear pair of electrons towards itself. As a result of this, partially negative charge will appear on fluorine atom. Secondly, hydrogen is less electronegative, so partially positive charge will appear on hydrogen atom. Hence, it is a polar molecule because it has positive pole and it has negative pole. On the other hand, consider a molecule of hydrogen gas. We can see that it has no positive pole and it has no negative pole, so it is a non-polar molecule. Thus note down all these important points. Now let me teach you my personal and easy trick which you will not find in any book or in any video format. For example, consider this ball. Let 5 Newton force act on this ball in this direction and 5 Newton force act on this ball in this direction. Where does the ball go? I mean, what is the net force on this ball? Well, the answer is simple. The net force on this ball is 0. Secondly, consider this example, where 10 Newton force act on the ball in this direction and 5 Newton force act on the ball in this direction. What about the net force? Well, the net force is not equal to 0. We can see that the net force on the ball is 5 Newton. Where does the ball go? We know that the ball goes in this direction. So in this case, there is net moment of the ball. We can see that ball is moving in this direction. Similarly, consider one another case. Let the ball experiences 3 forces of 10 Newton in 3 different directions. Here, again the net force is 0 and the ball doesn't go anywhere. Lastly, consider this case. Here, one force of 10 Newton act on the ball in this direction and another force of 10 Newton also act on the ball in this direction, while there is one force of 200 Newton acting on the ball in this direction. What about the net force? Well, the net force is not 0. The ball will move in this direction. So using this trick, we can easily calculate the dipole moment of any molecule. For example, if net force is 0, net dipole moment is 0, molecule is a non-polar molecule. If net force is not 0, dipole moment is not 0, molecule is a polar molecule. But how can we use this trick? Well, it is very simple. Consider diatomic molecule of AB2 format. Also we know that diatomic molecules are divided into 2 categories, homoatomic molecules and heteroatomic molecules. Remember that homoatomic molecules are made up of same atoms and heteroatomic molecules are made up of different atoms. For example, consider a molecule of chlorine gas and its structure. We know that on both the sides are the same atoms. Remember that same atoms exert same forces on shear pair of electrons. Let me repeat this important point. Same atoms exert same forces on shear pair of electrons. For example, if this chlorine exert 5 Newton force in this direction, then this chlorine also exert 5 Newton force in this direction. What about the net force? Well, we see that the net force is equal to 0. Hence the net dipole moment is 0. Therefore we say that this molecule is a non-polar molecule. Secondly, consider a molecule of hydrogen gas and its structure. Here we see that both the atoms are the same, so they will exert the same forces on shear pair of electron. Let this hydrogen atom exert 5 Newton force in this direction, and this hydrogen atom also exert 5 Newton force in opposite direction. Here the net force is equal to 0, so the net dipole moment is also equal to 0. Therefore we say that this is a non-polar molecule. Thirdly, consider a molecule of oxygen gas and its structure. Here both the atoms are the same. Let this oxygen atom exert 5 Newton force in this direction, and this oxygen atom also exert 5 Newton force in opposite direction. We can see that the net force is equal to 0. Hence net dipole moment is also equal to 0. Therefore we say that this is a non-polar molecule. Thus remember that all homoatomic molecules are non-polar molecules because atoms exert same forces on shear pair of electrons. On the other hand, consider hydrogen fluoride and its structure. Here the atoms are different, so they exert different forces on shear pair of electrons. Let me repeat this important point. Here the atoms are different, so they exert different forces on shear pair of electrons. We know that fluorine is more electronegative, hence it will exert 10 Newton force in this direction. Hydrogen is less electronegative, so it will exert 5 Newton force in opposite direction. What about the net force? Well, the net force is not equal to 0, hence the net dipole moment is also not 0. Hence it is a polar molecule. Secondly, consider hydrogen chloride and its structure. Here the atoms are different. Let chlorine being more electronegative exert 10 Newton force in this direction, and hydrogen atom exert 5 Newton force in opposite direction. The net force is not 0. The net dipole moment is also not 0. Hence this molecule is a polar molecule. Thirdly, consider hydrogen bromide and its structure. Here the atoms are different. Let bromine being more electronegative exert 10 Newton force in this direction, and hydrogen atom being less electronegative exert 5 Newton force in opposite direction. The net force is not equal to 0, hence the net dipole moment is also not equal to 0. Therefore we say that it is a polar molecule. Thus remember that all the heteroatomic molecules are polar molecules because atoms exert different forces on shear pair of electrons. Now let me teach you triatomic molecules of AB2 types. For example, consider beryllium fluoride and its structure. Here on both the sides are the same atom, so they will exert same forces on shear pair of electron. We know that fluorine is more electronegative. Let it exert 10 Newton force in this direction, and this fluorine also exert 10 Newton force in opposite direction. The net force is 0, the net dipole moment is also 0. Therefore we say that this is a non-polar molecule. Secondly, consider a molecule of carbon dioxide gas and its structure. Here on both the sides are the same atoms, so they will exert same forces on shear pair of electrons. Let this oxygen atom exert 10 Newton force in this direction, and this oxygen atom also exert 10 Newton force in opposite direction. We can see that the net force is equal to 0, the net dipole moment is also equal to 0. Therefore we say that this is a non-polar molecule. Thirdly, consider sulfur dioxide and its structure. There are two atoms of oxygen and there is one lone pair of electrons present on sulfur atom. Or we can say that there is one lone pair present on central atom. Remember that lone pair of electrons exert highest force in the molecule. Let me repeat this important point. Lone pair of electrons exert highest force in the molecule. For instance, oxygen atom being more electronegative exert 10 Newton force in this direction. This oxygen atom also exert 10 Newton force in this direction. On the other hand, lone pair will exert 50 Newton force in this direction. So here the net force is not equal to 0. Thus net dipole moment is not equal to 0. Therefore we say that this is a polar molecule. Thus note it down all these examples. Now let me teach you the polyatomic molecules of AB3 types like BCl3, BF3, Bi3, etc. Remember that these all molecules have the same geometry like this. For example, here fluorine atom being more electronegative exert more force on shear pair of electron. Let it exert 10 Newton force in this direction. This fluorine atom also exert 10 Newton force in this direction, and this fluorine also exert 10 Newton force in this direction. Here the net force is 0. Hence the net dipole moment is also 0. Therefore we say that this is a non-polar molecule. Similarly, all these molecules are non-polar molecules. Secondly, consider sulfur trioxide and its structure. Here, the atoms around the sulfur are the same. Let oxygen atom being more electronegative exert 10 Newton force in this direction. This oxygen atom also exert 10 Newton force, and this oxygen atom also exert 10 Newton force. We can see that the net force is equal to 0. The net dipole moment is also 0. Therefore, we say that this is a non-polar molecule. Thus noted down all these important examples. Finally, let me teach you AB4 types of molecules. Consider CH4, CCl4 and silicon tetrafluoride. Here, to make things super easy, these all molecules have the same type of geometry like this molecule. We can see that all the forces in all directions are the same, hence the net force is equal to 0. The net force is equal to 0, hence the net dipole moment is also equal to 0. Therefore, we say that all these molecules are non-polar molecules. Finally, let me teach you the structure of two bonus molecules. For example, consider water molecule and ammonia NH3 molecule. Can you guess the dipole moment of these two molecules? Well, we can see that there are two lone pairs present on central atom of oxygen. So this lone pair will exert 50 Newton force in this direction, and this lone pair will also exert 50 Newton force in this direction. We know that oxygen is more electronegative than hydrogen, so oxygen will exert 10 Newton force in this direction, and also oxygen will exert 10 Newton force in this direction. We can see that the net force is not equal to 0, hence net dipole moment is also not equal to 0. Therefore, we say that this is a polar molecule. In the case of NH3, there is one lone pair present on the central atom of nitrogen. So it will exert 50 Newton force in this direction. Nitrogen is more electronegative, so it will exert 10 Newton force in this direction. We can see that the net force is not equal to 0. The net dipole moment is not equal to 0. Hence, this is a polar molecule. Thus, by this way, we can find the dipole moment of any molecule. I hope that you have learned this trick of dipole moment.